Right, question 5, a nice little trig one. Given that 5 sine theta equals 2 cos theta, find the value of tan theta. It's just 1 mark, so it can't be too difficult. A, you should know that tan theta is equal to sine theta over cos theta. So if you look at this here, we want to get in terms of tan, so we need to be getting the sine and dividing it by a cos. So if we have 5 sine theta equals 2 cos theta, if we just divide this by cos, or divide this by this, you're going to end up with a tan. So what I'm going to do is I'm just going to divide both sides by cos theta. So divide by cos theta, divide by cos theta. So then we're going to have 5 sine divided by cos, which is going to give us 5 tan theta, which is looking good. And if you divide this side by cos, you're just going to get 1. So 2 times 1 is going to equal 2. We have to find the value of tan theta, so we need to divide by 5. Get rid of that 5, put it under here. I don't have to find the value of theta or anything, it's just tan theta. So 1 mark, tan theta is 2/5. Part B, solve for x being between 0 and 360 degrees. This thing here. Now, if we look at this thing, it's very similar to this thing here. The only difference is that there's theta here, but there's 2x here. So if we write this here, but instead of writing theta, we replace the theta with the 2x like they have there. So we're just using what we've done in part A to help us do part B. We have to give our answers to 1 decimal places, so we're solving it to find x. So tan 2x equals 2/5. We need to find a value first, so we need to shift in tan. So make sure you calculate as in degrees, because we're working x being between 0 and 360. And that means I get my answer, so 2x, not just x, it's 2x, equal to 1 decimal place, 21.8 degrees. Now at this point, I know it's really tempting to divide by 2 and get an answer for x. You will get one answer for x, but we need to find if there's more answers for x, and we can't divide by 2 and use the graph like we're going to do for the value of x. We need to stick with 2x for now. We'll half all the answers at the end. It's important that you do it at the end and not now. But because this value here is from 0 to 360, this is for x. That means for 2x, it's going to be double that. So that's going to be 720, and then double 0 is still 0. So we need to be picking off values from the graph between 0 and 720, because we're going to half them in the end, and that'll make sure they're between 0 and 360. The tan graph, if you want to use that, tan graph is going to be, I'm just going to make some space here and get rid of this because we don't need this anymore. Right, do it in a different colour because I can't see it. Right, the tan graph, I'm going to go from 0 to 720. You'll see actually you could probably work the values out without all the 0 to 720 values, but I'm going to do them anyway. Bad idea putting that there, it's a waste of space. Let's do it again. Start here. We're going from 0 all the way along, whoop, to 720. Now the tan graph's one that's I don't think it's known as well as the sine and cosine one, but every 90 degrees I'm going to put a mark. So 90, 180, 270, 360, 450, 540, 630, 720. Now the tan graph has asymptotes every 90 degrees. That's why I mark off every 90 degrees. With a sine and cosine graph, I do the same, go up in 90 degrees. And that's the sine and cosines have half peaks every 90 degrees. But the tan ones have asymptotes every 90 degrees. I'll do a different colour for... And it starts at 0. If in doubt, maybe start putting some values in if you're unsure what it looks like. But it goes 0 and it goes up and up and hits the asymptote there. What you don't want to do is do one here and here and here, because you'll get non-negative. It kind of misses out a gap. So there, it goes up here and does the same. Misses out, goes up here, does the same. Up here and does the same. And does the same. Underneath we get it's going up to infinity here, what happens is it's negative infinity there. So it's not really missing out. But try and learn this graph. But it's all these little waves, all these little are symmetrical. So it allows us to work out the values. Now, we know the tan of 2x, when we're shifting saying that, we got 21.8 degrees. We are going to half them all in a minute, but I just want to find out all the solutions between 0 and 720 for this. So 21.8 degrees, that was at 2/5, 0.4. So we'll just say here somewhere, 0.4. So we want to know all the times this red line at 0.4 is going to cross this bit here. And we can use the symmetry of the graph, because this first point here must be the one that was 21.8. So that little red gap is 21.8, which means that this red gap is 21.8. This red gap is 21.8. This red gap is 21.8, and I'm not going to do that one because it's outside the 720 range. So we can find all our solutions for 2x. We've got the first one. This next one will be 180 plus the 21.8, which is going to be 201.8. The next one will be 360 plus 21.8, which will be 381.8. The next one is going to be 540 plus 21.8, which is 561.8. So they're all the answers for 2x. Therefore, for x, we're going to half them all. And because we made the boundaries between 0 and 720, now when we half them all, they will be between 0 and 360. So half of this one is 10.9. Half of this one is 100.9. Half of this one is 190.9. And half of this one is 280.9 degrees. So there's 1, 2, 3, 4 solutions there. Done.